Hello everyone, welcome back. Today let's solve the 26th top coding interview question from 48 top coding interview questions curated by Leetcode. We'll solve this problem using Python. This is these problems. The next problem which we're going to solve is related to binary tree. It's a tree data structure. Basically, what is a binary tree? Binary tree is like one of the nonlinear data structures. So we stores the data in the form of trees, right? So what is binary tree? So the binary tree is basically it can have a maximum of two children. Maximum is two children, and then that's the main condition. So here this is the parent node, and this is the child node, and it has a maximum of two child nodes. 3 is the parent node, and then this is the these two 9 and 6, 9 and 20 are child nodes of 3, and 20 is the parent node for 15 and 17. So it has maximum children each node can have is true. Two is the maximum. That's the binary tree. Again, there are in binary tree there are many types of binary trees. But yeah, so this is the binary tree. The objective is given a root, let's say what we have to do is we simply have to find out maximum depth. Maximum depth, what is maximum depth is the the levels which we go down. So here in this case, if you see here, the root, the level is 3, right? 1, 2 and 3. So the maximum depth is 3. So it starts with 0 though, 0, 1, 2, but plus we have to add 1 to it. So it's basically 3, right? So 3 is the maximum depth of this tree. So basically we have to go at different levels, level 1, 2, 3. So that's the maximum depth. So whichever is having. So this stage, if you see here, we basically what we do is we'll iterate through. If I'm here, given root, right? I mean, given root node, I'll iterate through the left side and the right side of this node. I'll basically go to the left side and then right side, and then I'll check the maximum. Maximum again. Let's say I go right side. Again, I go to left side and right side. I'll go till the node whichever is the maximum. So in each node. So for the first time, I go left and right. All right, and then inside left again I go to left and right. If it is null, I'll just go back to head root node. So here, if you see here, first time I go to left and right, and the left side it is end. So I'll close it, and then right side I go again in the left side and right side I go. So that's how I iterate. So it's a very simple problem. How do you create a node, a tree node? So this is the syntax. This is how you define. You need a data node. The data. So basically, each node will contain the data, the address to the left node and the address to the right node. That's how the data is stored. If it is a last node, that's it will have a none, address as a none, because there is no next element. So here this node will have this value, and then address to the left node, address to the right node, and this node will have the value which is 20, and the address to the left node, address to the right node, and so on and so forth, right? So this is how you define this is the value and the left and right node. So how do I get it? Let me start with simple thing. If first of all, I'll put a edge case. If root is if not root, if not root, or if not root, if root is empty, basically I'll return 0. Root is not, that is basically 0, right? That's the condition. Else what I'll do is I'll basically take max. I'll call the same function in a recursive manner. I'll call the same function max of. I'll basically go to, I'll pass the left side. Root is the parent node. I'll pass the left side of the tree, root dot left. I'll pass the left side of the tree to this same function. I'll go to the left side first time, and then I'll also go max depth. I'll also go right side of the tree, right? I'll also go to the right side of the tree, root dot right. I'll pass the right side of the tree. So basically, each time I'll call. This is how I do it. So I'll basically take whichever is the maximum, either the left side or the right side. Again, when for the first time when you go to right side, again it will call left side and the right side, each node. So basically that's how I take it. Either it's in the right side or in the left side, whichever it is. So for the first time, let's say left side meaning this goes to here, right side meaning it goes to here, and then for the first time, I'll reiterate one more time. For the first time, it starts from here. Root left is this. It goes here, and there are no further right and left, so it stops here itself. Again, here it comes to the right. Again, it calls the left, and again it calls the right. So that's how these functions gets called, because it starts with 0. Always, you take whichever is either left side of the tree or the right side of the tree, whichever is the maximum, you take that, and then because it starts with 0, so I'll return +1. That's all. This is the code. I mean, this is that much easy code. That's all. So this basically, you take the left side and take the right side, take the left side and then take the right side. Again, in the right side, you go to the left and then you go to the right. There is one problem here, because this is a Python, so we have to call any function with the object, right? So I'll call self dot. Self is the object, so class name, right? So it's the self dot, because I'm calling the same function, self dot. Okay. So let me see. Yeah. So this your answer, expected answer. Let me submit. The code was correct. Yeah, it got accepted. So basically, it is a simple code. It's a recursive code. You're calling the same function again and again. In each time you're calling the same function. You go here, go to the left, and then go to the right. Again, in the left side, again you go to left and right, and so on and so forth. You go the till you take the either maximum of left side or the right side, and then +1 you add, and that's all. This is the easiest problem. I hope you liked it. Thank you for watching, and see you in the next video.